we'll cover the problem square root on algo monster. So here, we'll simply be given an integer, like 16, and we want to return its square root, which would be 4 in this case. Now, if we have something that has decimals, then we are supposed to truncate it, which means just get rid of the decimals and keep whatever the whole number is. So for example, if we get 8 as our input, the square root of 8 is like 2.83 and then some other stuff. So we drop everything after the decimal and we just return 2. Now, we're not supposed to use, the built-in square root function or anything like that. Now, this problem can actually be approached with binary search because we have a search space, right? We know that our answer must be between 0 and n. Let's say our answer is x, right? It must be greater than or equal to 0, and it must be less than or equal to n, because it can't be greater than n if it's the square root of n. And so we have our range here, and we could kind of do some sort of normal iteration, but that's going to give us something like square root of n time complexity, which is not ideal, because binary search allows us to get log n time complexity, which is actually going to be better. And so what we can do is we can search on this range. Now, the way we've done this before is we've seen that we can apply our filters. So we could do something like greater than, or like number squared, so number times number, greater than or equal to n. So if we had something like 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's consider this case. Then that would map to a Boolean array of false, false, false. Now here's true because 9 is greater than or equal to 8. So we get true, 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 true. If we found the first occurrence of a true, then we would get 3, which is not the answer we want because of the truncation. If we were told to round up, this would work fine. But we're told to truncate. So in the case where the square root does not have a clean answer, we want to be going to kind of the last false here. So we can simply flip the way we do this problem. So we will say, we'll use our filter as number times number, so number squared less than or equal to n. So then we get true, 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 because this one is 4. This one is 9, which is false. And then the rest of these are going to be false. And so what we will do now is we're actually going to find the last occurrence of a true. So previously we were finding the first occurrence of whatever's in the right half. Now we're finding the last occurrence of whatever is in the left half. And the pattern will be pretty similar. We'll just have to think a little bit more about it when we're writing it. Okay, so we'll have our left num, which will start at 0. Our right num is going to start at n. And then we can have our square root num, which will start at, I guess, what do we want to start it at here? I guess it should always be 0. Okay, I guess we could get a negative number for n, which could start to cause some problems. Okay, whatever. We'll go with -1 as our answer. Based on the problem statement, we probably should never actually return that, so I don't think it really matters. But just for consistency, we'll go ahead and stick with that. All right, now we'll do our same logic. Oh, I should mention I'm not calling these left and right index anymore because we don't actually have an array. We're just given a number n, so index wouldn't make that much sense. Now here we'll get our mid number. We can, how do we want to do this? We can make a function for it. The reason I choose to make a function for this is kind of up to you. You don't have to do this. But I choose to because it would be nice in a large code base to have this kind of logic centralized. You can imagine if we just wrote the math in line right here, there are probably lots of places in a big code base where people write a binary search. And maybe one day an update comes to JavaScript that all of a sudden makes it so that you don't have to do this logic anymore for some reason. They make some big change, and maybe you can just do it the normal way, or maybe you have to do it some new way. Then you have to go through all of your code base, you have to find all of the references and update them individually. But if everyone is using this like get min num function that's in some utilities file, then you come here, you make the update, and boom, everything should still be working as long as the function still behaves the way it's supposed to. So that's why I personally prefer to do it this way, but it's up to you. Okay, now we'll use our condition, which is whether the number, so mid num times mid num, is less than or equal to n, our target number. Now, If it is, that's like a true here, for example, then we know that this could be our answer, but there could be an answer more to the right of us. So what we'll do is we'll update this to say, hey, this is a potential answer, and then go ahead and search everything to the right of me. So we'll grab the left index, or left number, and move it to be midnum plus 1. Then we can have our else condition, which is, we have a false. We have something like this. So we know we need to move more to the left to find our right answer. So we'll grab our right num and move it to be midnum minus 1. In the end, we simply grab this square root num right here, and we can return that. Now, one point I want to make right here, remember that we're updating this, but we don't actually, we sometimes update this when we have the wrong number. But that is okay, because we know that we're always in one of two cases. Either we update this to be the right answer, and then, so that'd be like this, and then we end up searching this array for a true, which we know that because 2 was the right answer, it's not possible that there is a true here. So that's fine. It'll never get updated again. The other case is that we have something like this, and then we update the square root num. But afterwards, we're going to search this array, which does have a true. So we will overwrite the value of square root num later on. So we can safely do this logic, because we know either we'll have the right answer or it will be overwritten with the right answer later on. All right, and it looks like we passed the test they have. All right, so that's all for this video, and thank you for watching.